For most of human history, we believed Earth was the center of everything, the very heart of the cosmos. The sun, moon, and stars all seemed to revolve around us, painting a picture of a universe that spun for our benefit. This geocentric model was more than a guess. It was a worldview, deeply woven into the fabric of science, philosophy, and religion for millennia. It made us feel important, as if the universe was built for us, and every celestial event was a message meant for humanity. Ancient astronomers like Ptolemy created elaborate systems to keep Earth at the center, inventing complex epicycles to explain the strange paths of the planets. For centuries, this model worked, until it didn't. The motions of the planets became too tangled to explain away. The real revolution began with Copernicus, who dared to suggest the sun, not Earth, was at the center. His idea was radical, even dangerous. The heliocentric model explained planetary motion more simply, but it was a blow to our ego and our sense of cosmic importance. Suddenly, Earth was just another planet, orbiting an ordinary star in a vast expanse. Even then, we clung to the idea that the sun was the center of the universe, with the stars as a fixed, unchanging backdrop. We'd left the center of the solar system, but not the universe. Our sense of place was still limited. It took time, and mounting evidence, to realize our cosmic address was far more complex and humbling than we ever imagined. We were like a family who learns their house isn't the whole city, but still thinks their city is the world, unable to see beyond their familiar streets. The journey to our true place required us to look beyond our neighborhood, to peer deeper into the night, and face the vastness of the cosmos. Each step forward forced us to let go of old certainties, challenging our pride and our understanding of reality. Our demotion from the center was just the beginning, a necessary step in a much larger journey. The universe was about to get much bigger and our place in it much smaller, but infinitely more fascinating. Long before telescopes, people gazed up at the night sky and saw a mysterious, glowing band stretching from horizon to horizon, the Milky Way. It was a sight that inspired wonder, stories, and legends across cultures for thousands of years. Its true nature, however, remained a mystery for centuries. People wondered, was it a river of light, a path for the gods, or something else entirely? Everything changed in 1610, when Galileo Galilei turned his newly built telescope toward the Milky Way. For the first time, he revealed that this glowing band was not a cloud, but was made up of countless distant stars packed so closely together that their light blended into a milky haze. Suddenly, the universe seemed far more crowded and complex than anyone had ever imagined. The night sky was no longer just a backdrop, but a window into a vast cosmos. The Milky Way was revealed as a vast, intricate structure, not just a simple cloud of light. Early thinkers like Immanuel Kant and Thomas Wright proposed that the Milky Way was actually a flattened disk of stars, and that our solar system was located somewhere inside this immense structure. When we looked along the disk, we saw a dense, bright band of stars. When we looked out of the plane, there were far fewer stars to be seen. It was like standing in a dense forest. Look through the trees, and you see a wall of trunks. Look up, and you see open sky. This simple analogy helped people visualize our place within the galaxy. Using this idea, astronomers began to sketch the first rough maps of the Milky Way, trying to understand its true shape and our position within it. We realized we lived in a flattened city of stars, not at its center but somewhere within its sprawling neighborhoods, surrounded by billions of other suns. The Milky Way was our cosmic home, but its true shape and our exact place in it were still shrouded in mystery, waiting to be discovered. The journey to map our galaxy had only just begun, and astronomers were eager to unlock its secrets. The next step was clear: count the stars and try to measure the galaxy's size and structure. And that's where William Herschel enters the story, ready to take on the challenge and change our understanding of the Milky Way forever. In the late 1700s, William Herschel and his devoted sister Caroline embarked on an ambitious quest to map the vast expanse of the Milky Way galaxy. Their partnership, fueled by curiosity and determination, would change our understanding of the cosmos. Using powerful homemade telescopes crafted by William himself, the siblings painstakingly counted stars in every direction, dividing the sky into countless patches and recording their observations night after night. Herschel made two key assumptions: that all stars shone with similar brightness, and that his telescopes could peer all the way to the very edge of the galaxy. He reasoned that regions with more stars meant the galaxy stretched farther in that direction, while fewer stars suggested the edge was closer to us. After years of meticulous work, Herschel unveiled a map of the Milky Way, a flattened, grindstone-shaped galaxy, with the sun sitting proudly at its center, a vision that seemed to make sense at the time. It was a satisfying and elegant result, but ultimately, it was wrong. Herschel had no way of knowing about the existence of interstellar dust, vast clouds that block and dim the light from distant stars, hiding much of the galaxy from view. His telescopes, though advanced for their time, were peering into a cosmic fog, making the galaxy appear smaller than it truly was, and placing us at the center by mere illusion. The real structure of our galaxy, and our true position within it, remained hidden behind this veil of dust and darkness. Herschel's work was groundbreaking, a giant leap for astronomy, but it was inevitably limited by the tools and knowledge of his era. To truly measure the vast distances of space, astronomers would need a new method, a cosmic yardstick that could reach across the stars. The answer, surprisingly, would come decades later from a quiet, meticulous observer working at Harvard Observatory. The search for a reliable way to measure the universe was about to take a dramatic turn. The fog was about to lift. Enter Henrietta Leavitt, whose discovery would forever change our view of the cosmos. To map the galaxy, astronomers needed a way to measure vast distances, a standard candle. Henrietta Swan Leavitt, working at Harvard in the early 1900s, found the key. She studied Cepheid variable stars, which pulse in brightness at regular intervals. Leavitt discovered a direct relationship. The longer the pulsation, the brighter the star. This period luminosity law let astronomers calculate a Cepheids' true brightness from its pulse. By comparing true and apparent brightness, they could measure distance. Leavitt's discovery was the cosmic yardstick astronomy needed. It revolutionized our understanding of the universe's scale. Though she didn't receive recognition in her lifetime, her work paved the way for the next leap. Now, astronomers could finally measure the true size of the Milky Way and beyond. The universe was about to expand again, the great debate was coming, and Edwin Hubble was ready. In the 1920s, astronomers argued, were spiral nebulae like Andromeda part of our galaxy, or separate island universes? The answer depended on distance. Edwin Hubble, using Leavitt's method, searched for Cepheid variables in Andromeda. He found them, measured their periods, and calculated their distance. The result, Andromeda was nearly 1 million light-years away, far outside the Milky Way. This proved Andromeda was a separate galaxy, not a cloud within ours. The universe suddenly contained millions, maybe billions of galaxies. Our Milky Way was just one among many. Hubble's discovery forever changed our perspective. We were no longer at the center of anything. But one question remained. Where were we inside our own galaxy? The search for our true address continued. The answer would come from globular clusters. Harlow Shapley was about to redraw the map. The Copernican revolution wasn't over yet. Our place was about to shift again. Harlow Shapley set out to find our true location in the Milky Way. He focused on globular clusters, dense, ancient star swarms orbiting the galaxy. Shapley noticed these clusters were concentrated towards Sagittarius, not around the Sun. Using Leavitt's Cepheid method, he measured their distances and mapped their distribution. The center of the cluster sphere was tens of thousands of light-years from us. Our solar system was not at the center but in the galactic suburbs. Shapley's work dethroned us from the center of the Milky Way. We were just another resident in a vast stellar city. The galaxy was far grander than Herschel imagined. Our true address, a spiral arm, far from the core. But what did our galaxy actually look like? Knowing our off-center position was a breakthrough, but the Milky Way's true shape was still a mystery. Interstellar dust blocked our view, hiding the galaxy's structure. The solution came with radio astronomy in the mid-20th century. Radio waves, unlike visible light, pass through dust, revealing the galaxy's hidden features. By mapping hydrogen gas with radio telescopes, astronomers traced the Milky Way's spiral arms. They confirmed our galaxy is a majestic, rotating spiral. Further studies revealed a central bar and a supermassive black hole at the core. Our Sun orbits in a minor arm, the Orion Cygnus arm, between larger arms. The Milky Way's map was finally coming into focus. We could see our place in a vast dynamic structure, but to truly map billions of stars, we needed new technology. Enter the Gaia mission. Mapping the Milky Way in detail required knowing the positions and motions of billions of stars. The European Space Agency's Gaia mission, launched in 2013, set out to do just that. Gaia scans the sky, measuring the position, brightness, and motion of over 1 billion stars. By tracking parallax and proper motion, Gaia creates a dynamic 3D map of the galaxy. The data is revolutionary, revealing the Milky Way's structure, history, and ongoing evolution. We can now trace the orbits of stars, map spiral arms, and uncover remnants of ancient galactic collisions. Gaia's map is the most precise ever made, showing our place with incredible accuracy. It's like having a blueprint of our cosmic city. Thanks to Gaia, we see the Milky Way as a living, changing galaxy. Our understanding grows with every new data release. The journey from Galileo's telescope to Gaia's billion-star map is a triumph of human curiosity. But why does knowing our place matter? The answer goes to the heart of what it means to be human. Why spend centuries mapping our place in the cosmos? This quest is driven by curiosity, the same force that led us to explore new worlds. Each discovery has taught us humility. We are not the center, but a small part of a vast universe. Yet knowing our place makes us precious, not insignificant. The elements in our bodies were forged in ancient stars. We are made of stardust. Understanding the galaxy is understanding our own origins. This knowledge inspires us to ask big questions. Are we alone? What else is out there? Mapping the Milky Way is a guide for future exploration. The work of Herschel, Leavitt, Hubble, Shapley, and Gaia is about looking forward as much as back. We began thinking we were everything, only to find we're a speck in a grander story. But in that realization, we found connection to the cosmos and to each other. Our place is here, on this pale blue dot, looking up and wondering. And that is a wonderful place to be.